Hello everyone. Today we are starting a new series on manual testing. So this entire video series will have a number of parts in which we look at different testing topics. Since today is the first part, we'll be looking at what is testing and why do we test? Why is testing important? So let us get started. Before we talk about testing, we have to talk about quality a little bit. So, if you hear the term quality, you think about some characteristic or some property of an item, a person, or a system. So, if we break it down into its components, quality means that whatever system we are talking about, whether it is a simple system like a pen used for writing, or whether it is a smartphone, or whether it is a vehicle, or whether it is a software application. So, quality means meeting the specifications. Now, higher quality is more desirable because that means that it is able to do things better, it is more useful for the user. So, always there is a need for going towards higher quality. But different systems have different quality. Some are low quality, some have medium quality, some have high quality, some have very high quality. But quality consists of all these sub properties or sub characteristics. So first of all, it is meeting the specifications. Every system has some specifications in terms of what inputs it accepts, what processes it does, and what are the outputs it produces, what are the different workflows in it, how do we use the system, etc. So all these are the specifications. If you have ever considered buying a vehicle such as a car, you would have looked at something called the specifications, which says what is the length of the car, what are the other dimensions of the car, how many passengers can sit in the car, what is the power of the car, what is the torque of the car, what is the wheelbase, etc. So all these are specifications. So quality means how the system is meeting the specifications. So let us say, take the example of an email application. Everyone uses emails these days. So the specification of an emailing system or email software can be that it allows the user to read an email that is sent to the user. The user has an email address. That email address uniquely identifies that particular user. The user is able to read emails sent to this email address. The user is also able to write an email and able to send the email to another email address, to one or more addresses. So all these are specifications. So quality means how the system is meeting the specification. Another definition of quality is fitness for purpose. Is it fit for the purpose for it is which it is going to be used? So if we have the email application example, so there we can see that the fitness of purpose means that the user should be able to read a lot of emails. The email system should be able to store all the emails of the user. The user should be able to write the emails and be able to send many emails. So that is the fitness of purpose. We can take example of another software such as for submitting the tax returns every year when we have to submit the income tax returns. So once we input the incomes, different incomes into the system, it should be able to calculate the tax correctly, whatever tax is supposed to be paid, and then create the tax return in the format that will be accepted by the income tax authorities. So that is the fitness for purpose. So quality means whether the system is fit for the purpose or not. Another definition of quality is around the features. So are there many useful features in the system or not? So let us take the example of a calculator software. So when we use the calculator software, we need it for the basic operations, addition, subtraction, multiplication, division, and also other operations like finding the log, sine, cos, square root, square, all these operations are there. So all these are the features. So if the system has all the necessary features which are useful to the user, so we say it has good quality. Quality can also be described in terms of other characteristics such as performance, whether the system is able to work at high speed or not. It can be in terms of reliability, whether the system is able to work for long periods of time giving the correct output or not. Whether the system is maintainable, meaning that if we need some changes to be made to the system, whether it is possible to make those changes. If some part of the system is not working correctly, is it possible to change that part of the system? So that is also one of the characteristics or one of the properties of quality. Then another quality characteristic is security. For example, if you have a banking application which you use to operate your bank account, so you want it to be very secure. No other user should be able to see your account balance and never should be able to perform any transaction on it, such as transferring any funds from your account to another account. So security is very, very important quality characteristic in a banking application. Another quality characteristic is portability. So portability means that you can take the system to another environment and there it works well. For example, if it is a software, so the software works in Windows. So if you take it to the Linux environment, does it work in Linux? Does it work in the Mac operating system? So that is an example of portability. So wherever we find that the system meets the specifications, is fit for the purpose, has a large number of useful features, is performing well, it's reliable, it's maintainable, it's secure, it is portable, we say it has high quality. So that is the understanding of quality. Now why have I explained quality when I am going to explain testing? Well, testing gives us useful data about the quality of the system that we have to test. So let us see how. So first of all, let us start with the basic definition of testing. What is testing? Well, testing means operating the software, and when we operate the software, we want answers to some questions. So these are the questions. So the first question is, does the software meet the requirements or not? So every software has some requirements. These requirements may be in the form of requirement specification, or they may be in the form of user stories, or they may be in some other format. So we have to find out in testing, does the software meet the requirements or not? So if there are 100 requirements, we have to test whether the software satisfies each and every one of those requirements or not. Even if the software is meeting all the requirements, we have to ask further question, does it meet the requirement fully? So for instance, let us go back to the calculator example. So in calculation, let us say that there was a requirement that we should be able to perform the basic addition and subtraction up to 10 operations in one go. Okay, so the calculator application can perform 10 addition or subtractions in a series, and then it can calculate the result for you. So we found out that the calculator application is able to perform the addition operation, it is able to perform the subtraction operation, but is it able to perform these operations 10 at a time? Okay, so that is the meaning of meeting the requirements fully. So the software does not have to just meet the requirements, it has to meet each and every part of the requirement. So if you have a requirement which has a main section and subsections, the software has to meet the main requirement also and each of the subsections also. Then we also try to find out answer to the question, does the software meet the requirements correctly? So let us think about the tax return software, and there we find that for the basic income it is computing the tax correctly, but when we give additional income it is not computing the tax correctly. There is some problem. So that is the advantage of testing. It tells us whether the requirements have been correctly implemented in it or not. The second question we have to ask ourselves is, does the software work correctly? So testing always involves making the software work. We cannot just look at the software, look at the user interface and decide whether it is correct or not. We have to test it. Testing means executing the software. So we have to do some operations in the software, we have to enter some data, we have to do some process in the software, then we have to look at the outputs and compare those outputs with what we are expecting. So doing all this, we can find out whether the software is working correctly or not. Then another question in testing is, do all the features work? So whatever features are supposed to be there, first of all, do all those features exist in the software? And if they exist, do all those features work? And when they work, do they work fully and they work correctly? So there is an overlap here between the requirements and the correct working of the software. So we have to test for each and every requirement, make sure that each requirement is implemented fully and correctly in the software. And we also have to find out whether the software is working correctly and all the features are working correctly. One of the important byproducts of testing is the defects. So we find out, are there any defects in the software? So sometimes there is a problem in the software. For instance, if we are adding two numbers, we are expecting a particular result to be there, but it is not that result which is shown by the software. So that means there is a defect. So defects are problems in the software for the users. So in the presence of a defect, the user will not be able to do their particular work. They will not be able to use that particular feature. So it becomes important that defects are reported to the developers, and developers take actions to remove those defects, and then again the software is tested and then shipped to the users. One of the questions that is answered when we do the testing is, what is the software quality? And quality is measured on different criteria. It is measured on different parameters. Once we have checked whether the software meets all the requirements, whether it is working correctly, whether there are defects or not, we can make some judgment about the software's quality. And we can have data that supports this judgment. So let us say that there is a software, it has 10 features and 10 requirements, but it also has 5 defects in it, and it is its speed is low, that means the performance is low. So we can make some judgment about the software quality. We can say that it is not of a good quality, because for a small feature set of 10 features, it is having 5 defects, and there are also other quality problems such as the slow speed of the software. So once testing is done, we can have the idea about the software quality, and this data about the software quality is very useful. This is the data that as a tester you provide to the other team members, you provide it to the developers, you provide it to the management, you provide it to the client, so that they can take an informed decision whether the software is ready to be shipped to the users or not. So this is a very important data that is collected when testing is done. Along with the data of software quality, we can also find out what is the overall risk if the software is shipped. So let us say that there are some minor defects in the software, and so at that time the question becomes, so is it wise to ship the software to the users with those minor defects, or do those defects have to be fixed before the software can be shipped? So once you have the data for the software quality, this data is generated by testing, you can make the assessment what is the overall risk in shipping the software, and then the entire team and the management, they can decide whether the software will be shipped or whether the defects will be fixed or not. Sometimes due to business objectives, ship date is important, and new releases of the software are also planned. So certain minor defects can exist in the software, and the users can be informed that these are the known issues in the software and these will be fixed in the subsequent release. Or the management can take the decision that no, we want to fix each and every defect that is found in this round of testing, and then ship the software. So whatever is the decision is based on the overall risk. So as a tester, your role becomes very critical. Your role becomes to test whether each and every requirement is fully and correctly implemented in the software. Does the software work correctly? Do each of the features work? Are there any defects in the software? So you report all these things, and also you gather all the data about the software quality, and based on your data you can suggest what is the overall risk if the software is shipped. So as a tester, your input becomes very important, because your inputs are the data for the management and the client to ship the software or not, and that is about it. One of the misconceptions about testing is that it improves the quality of the software. Well, that is not correct. Testing itself does not improve the quality. Why? Let me explain. Testing does not involve changing the software. In testing, you do not change the software. You simply execute the software, you inspect the software, you enter inputs into the software, you make a number of checks in the software, but you are not changing the software. So it is impossible for testing to improve the quality. The only thing testing does is it gets the required data for the current quality of the software, the current quality of the system that is being tested. So this data is important, and once as a tester you have found the defects and you submit those defects to the developers, when the developers fix those defects, that is when the quality of the software improves. So let us say in the email application you find that if you are sending an email to more than 5 users, then the email doesn't go. So that is a defect. So in testing, you have just found this particular defect, that it is not possible to send email to 5 or more users in a single email. When you submit this defect to the developers and the developers find out what is the problem in the source code and they fix the problem, that is when the quality improves. So testing by itself does not improve the quality. Testing gets the data about the quality. So let us go back to the beginning and just do a recap on what is testing. So put very simply, testing means executing the software to find out quality related information. Testing involves finding out whether each and every requirement is implemented in the software, whether each requirement is implemented fully and correctly. Does the software work correctly? Does each of the features in the software work correctly? And are there any defects in the software or not? And side by side, testing also generates quality related data for the software. It finds out what is the overall quality characteristic of the software, and based on the quality risk, it is possible to estimate the overall risk if the software is shipped in its current state. So that is the testing. Now, why testing is important? Why it is important is basically it gives us data. It gives us objective data about the software that is being tested. It tells us whether there are any missing requirements, some things are missing in the software, whether some things are incorrect in the software, whether there are defects in the software, and it tells us what is the overall quality. Now, all these things are very important from a business point of view, because the software is meant for the users, and users need to be satisfied when they are using the software. So it is very important that an objective testing is done, and in objective testing all these things are found out. So that is why testing is very important, to find out and estimate ahead of time whether the users will be satisfied or not. In some cases, if users are not satisfied with the software, they can simply reject the software. They can say, no, we don't want it, it doesn't work properly. So that can be business loss for the company that has produced the software. In some cases, there will be no sales if the quality is poor, as shown by testing. So that is again lost revenue for the company. In some cases, for example, in custom software development, there are penalty clauses in cases, and if there are defects in the software that is shipped, so then the company has to pay the penalties because there are the defects present in the software. So that is why testing becomes very important. Testing gives the objective data to find out in advance whether the users will be satisfied, whether there will be sales, whether there will be no penalties when the software is shipped. So it becomes very important from a business point of view to find out ahead of time what is going to be the result when the software is given to the users. So that is why testing is very important. Many companies test their products, and testing has become really popular in the last 10 or 20 years. Before there used to be less testing, but now we have different types of testing that is done on software products and services. We have static testing, we have dynamic testing, we have different types of testing like functional testing, performance testing, security testing, usability testing. So the purpose is to find out all the possible problems in the software, and then to correct those problems and then give the software to the users. So testing is a very popular area of work, and it provides a very good value to the business in terms of the quality of the software. So that is why testing is very important. As a tester, your role is very important, because you are the one who will be executing the software. You are the one who will be responsible for checking whether each and every requirement is correctly implemented, whether the software is working correctly or not, whether there are any defects or not in the software. So as a tester, you provide a lot of value to the business so that they can estimate what is the quality of the software, and then they can take the appropriate decision on basis of that. Well, this is all for this video. In the next video, we'll look at what to test and then move on to other topics. So see you next time.